May 15th, 2014, WIKISPEED Lynnwood, Washington, United States shop. Here we are with the interior module mold. It's a plywood mold that's been nailed together and screwed together and then also adhesed together, and it's been lined with taped in tarps or plastic drop cloths as a release agent, and then with cellophane. What I'm doing here is trimming off using scissors and safety gloves the excess carbon fiber. We can see that how the cloth is laid in the mold directly results to how much cloth is excess that needs to be trimmed, which then can be reused in small pieces. But depending on how we lay the cloth inside, we might call that the ply orientation, and then the layup schedule determines how much waste or drop we have. It looks like the most efficient method for this mold is to have 50-inch wide fabric come over the outside edge, drop down, and come in the inside edge, but not coming to this edge. So it starts here and stops just past the midpoint, flows in, down across the bottom, and up, and then cut directly at the 4-inch boundary on each side, and then taped in place for epoxy. Then the next sheet, also 50 inches wide, overlaps in the middle, and it'll come all the way to the rear edge, but not against the wall, so we don't have this wrinkling. Down, flat, up, and over, and cut to 4-inch length. Then a final piece is taken running the width, and it will be pleated at these corners and fills in this and gives us a double thick bottom, which is what we'd want for seat anchoring once the ply layup. And we do that once the ply layup is complete. And we do that per type of sheet, starting with an E-glass, then a biaxial mat, and then the honeycomb floor, and then a carbon fiber top layer. The most stressed layer is always at the surface. And that should reduce wrinkling and the amount of drops, because all this is excess that we can reuse as thin strips, but we can avoid it if the layup schedule is a little bit more precise, and that also should reduce the amount of wrinkling.